So we're all familiar with taking X-rays, right? But have you ever heard of N-rays? So the more proper term for it would be actually neutron imaging. And instead of using X-rays, like you would in a dental X-ray or when you need to take an X-ray of a broken bone, you would instead be using neutrons, and you typically aren't taking images of people. So why would we use neutrons instead of X-rays to take an image of an item? Well, they give night and day different images than X-rays. They're actually complementary. So this image here, which is provided by Phoenix Neutron Imaging, which is a part of Shine, who is sponsoring this video, is a image of a jar, and it looks like it's filled with just staples. And this here is an X-ray image. And this here is an image taken using neutrons. And you can see in the center of that mass of staples is a little Playmobil figure. It almost looks as if the neutrons act in almost the opposite way as X-rays, passing through the more denser metal, but then being stopped by the lighter hydrogen and carbon material that make up a Playmobil figure. So why the difference in the images? It all has to do with what makes up X-rays and neutrons and how they interact with matter. X-rays typically interact with the electron cloud, or the orbital electrons of an atom, and the more electrons that a specific element has, the more likely that an X-ray will interact with that specific element. Neutrons, on the other hand, the neutrons don't interact with the electron cloud at all. They interact with the center of an atom, the nucleus of an atom. I created this figure here to kind of explain how it all works. This here would be your larger atom with that much larger electron cloud, and this is a much smaller atom with a much smaller electron cloud. A neutron, let's say it's passing through this larger one, has a lot more electron cloud space to pass through without interacting with the nucleus of the atom. But up here, the nucleuses are much more closely packed with each other due to that smaller electron cloud. So a neutron passing through here has a lot easier time interacting with the nucleus. By taking advantage of how neutrons and X-rays interact with matter, you can use both techniques to get a more full picture of what's going on in different situations. One example of using this sort of technique is in turbine blades on aircraft, a certain thing that you don't want to fail on you. You can take an image of every single one of these turbine blades before putting it in, making sure that there are no defects in any of the turbine blades. This sort of technique is called non-destructive testing and can be used in both neutron testing as well as X-ray. And you can see here in the neutron, you can see a lot more detail. And that's because the neutrons aren't interacting with the metal as easy. And they used gadolinium to show the defects that are in here as a contrast, because gadolinium is one of those things that neutrons do interact. So it causes any defects to kind of show up as white on these images. Here's another really cool example of using neutrons, and in this one you can actually see the water moving through these flowers here. Water has a lot of hydrogen, and as I mentioned, neutrons interact with hydrogen very well. And I just think that this is really cool to look at. Another use case would be looking into ammunition, and this here is an X-ray using X-rays instead of neutrons, and you can see, you can't see inside any of this. This is the lead here, and you can see the casing. You can't see through that at all. And this here is an image taken with neutrons, and you can see right through the casing and see the propellant powder in there, and each individual grain of propellant in the cartridge. So not only can you create a static image using neutrons, but you can also create an entire 3D model of something. And this right here is a GIF of a flashlight taken at Phoenix. And what Phoenix did is they're actually the first to commercialize doing 3D neutron imaging. So as you can imagine, there are so many different ways that we can take advantage of this neutron imaging, and we've really only scratched the surface in the applications of neutron imaging.